Hello and welcome guys. So in this video we are going to perform text vectorization. So in the last video we started this project and we did this data pre-processing by applying this clean text function on our data set, and after that we splitted our data set into training set and test set. So if you're new to this video, then please watch this playlist from beginning. So for text vectorization we are going to use Tensorflow Text Vectorization layer. So let me show you first. I will provide the link of this documentation in the video description. So to access this, you can use this tf.keras.layers.textvectorization. So in this we have this these all parameters. So first let us understand exactly what it do. So first, the processing of each examples contain the following steps. It performs standardization of each examples by converting those examples to lowercase and removing all the punctuations. Then it split all the each examples into substring. It recombines substring into tokens if we pass n-grams, like we have here n-grams also. So if we provide n-grams, then it will take whatever value we will pass. So based on that, it will recombine the substrings, and it will index the tokens, and then it will transform each examples using these index either into vector of int or dense float vector. So for that, first we have to build the vocabulary. So once we develop our vocabulary, then according to that vocabulary, it will give index to each words. Okay, so this is what this text vectorization perform, and these are the parameters which we are going to use in our text vectorization. This is the meaning of each parameter, like this is max token. So max token means that maximum size of vocabulary for this layer. Once I implement these things, then you will understand these things better. Okay, so let's go to the VS Code. So first, to access this text vectorization, I'm going to use here from TensorFlow .keras .layers. I want to import text vectorization. Okay, so this is what I need as of now. So let me run this. Okay, now I will define my vocab size. So right now I am considering it 20,000. Why 20,000? Because I tried on different vocabulary. If I take all the unique words from this data set, then it will be very big and it will take too much time to train our model. So that's why I'm taking this many number of vocabularies. So 20,000 is the good number to train our model on this machine. So that's why I'm taking this much. So if you can increase also this vocabulary, so increasing vocabulary makes your model to understand too much words. Okay, so that's why you can tune this, and right now I'm using 20,000 here. Okay, and there is one more parameter is max len. So max len I'm passing here is as 200. So what is this max len? Let's go to the documentation. Here you will get what is exactly the max len. So max len is basically the output sequence length. So if I'm passing that output mode as integer, then only we are going to use this. So max len is basically how many words or how many tokens we want to vectorize. That is basically the max len. Okay, I take one example like this. Okay, so in this we have 1 2 3 4 5 6. These are the tokens. Okay, so if I'm considering here max len as 200, then it means that I will only vectorize first 200 words and rest all I will not vectorize. Okay, that is the meaning of that. And suppose we have 10 words in one example, so all 190 word will be given as zero value. Okay, we can see that how many number of words we have in our data set. So let's compute that here. Okay, so to compute that, I'm giving one logic sum is equal to 0, and for I'm iterating over for I in x, I'm taking full x dot to list. So x dot to list will convert my data frame in the list. Okay, x means full training example including training set and test set. So I'm taking that, and what I'm going to do, I'm defining here sum. which is initially, which is 0, and I'm adding in this sum. What I'm splitting my data, I'm iterating over each examples, and I'm splitting it based on space. Okay, based on space I'm splitting it. This will give me total sum of how many number of words we have. Basically I'm calculating the total number of tokens present in this. Okay, and I will take the average. Okay, so I'm taking here average of this so that I can understand, okay, how many average number of tokens are there. Okay, so that's why I'm doing this. So if you do like this and if you print here average, then you will get here 119. So I'm what this is doing, it's calculating the number of tokens in each examples. Okay, so suppose in first example we have 100 tokens, so 100 will get so I'm adding 100 to this sum, and after that I'm dividing it by total number of example, so it's giving me average number of tokens present in the data set. Okay, so this is giving average number of tokens, and so that I get an idea, okay, so on an average how many number of tokens each examples have. Okay, so this is the value. So 119 is the average number of token we have. So I've taken some little bigger max length, so which can cover almost everything. Okay, so that's why I've taken here 200, and also I tried with different max length and I'm getting good result on this. That's why I have taken this. Okay, now let's define my vectorize layer. For that, first I have to instantiate my text vectorization, and in this first thing I will pass max token. Max token is my vocab size, so I'm saying that maximum you have to consider this many number of words. And output mode I am writing here, output mode is equal to, I'm taking here int, and as here I have defined output mode as int, so I have to give output sequence length also, sequence length, so which will be my max length. Okay, so this is that. Let's run this. So here if I go here, then this output sequence length only valid in int mode. If set, the output will have its dimension padded or truncated to exactly the output sequence length. Okay, so this is the meaning of this. It means that if we have less than 200 tokens in any example, then all remaining tokens get padded in that vector, and if somewhere we have more than 200, then that tokens get truncated to 200. Okay, so that is the meaning of output sequence length. And here output mode we have int multi-hot count tf-idf. So these are some output mode which we can try, but here I am trying this. So if you try this tf-idf, then it will apply tf-idf algorithm and then it will vectorize it. Okay, so you can try this thing also, but we are going to use LSTM model, so that's why I have not tried this. Okay, because later we have to train this full architecture. So if we try tf-idf, then it will make our training very slow. Okay, so that's why I'm trying this. And after that, what we have to do, so we have successfully created our vectorized layer. Now we have to build our vocabulary. Okay, so in this, to build vocabulary, you have to use vectorize layer.adapt, and here you have to pass your xtrain. So it will use your xtrain and it will build the vocabulary on that. Why I am not passing here x? Because I want I don't want to give information of test set to this vectorized layer, so that when we are going to perform testing, and that time we can see that, okay, so how this entire architecture is behaving on some new or unseen data points. Okay, so that's why I'm just giving here training set. Okay, so let's build our vocabulary on this. So we will build our vocabulary on training set, and we'll build our model, and then we'll test on test set. Okay, so that's why I'm not giving anything here. So if you want to see the vocabulary exactly, so you can write here vocab, and you can give here np.array, and here you can take vectorize layer, because you now build the vocabulary, so you can get this thing. So you can use here get vocabulary. Okay, and after that, if you want to see some of the initials, so you can write like this. So you will be able to see first 50 vocabulary. Okay, so this is the first 50 vocabulary. So in this, we give here this unknown tag. While doing the vectorization, if some word is not present in this vocabulary size is 20,000. If there are some words in the training examples or somewhere which is not present in this 20,000 value, okay, so what it will do, it will map that, it will vectorize that to this indices. Okay, it will give this unknown tag to that word. Okay, so that is the meaning of that. If I show you the shape of this, then we have this 20,000 words. Okay, so what it do exactly, so it will take our training set and it will compute the frequency of each words, and then it will rank them, and it will only take first 20,000 word based on the frequency. Like this movie is present too many times in this entire data set. So that's why this vocabulary we are getting here this at first. Okay, then film, these are some most frequently occurred words in the training set. This one, like, time, good, characters, so these are most occurring words. So similarly we have 20,000 words. Okay, so it will rank them based on frequency and it will take first 20,000 word. So that's how we can build the vocabulary. And also there is another way, like if you go here, then you can see the parameter, this vocabulary. So you can also pass this vocabulary here as a parameter. So for that you have to build this vocabulary before this. So you have to use your own logic and you have to build the vocabulary, and you can pass that vocabulary here also. So if you are doing like that, then you don't have to use this adapt and build vocabulary. So here we are building our vocabulary using TensorFlow vectorized layer. Okay, using that we are building the vocabulary, but you can also pass that vocabulary as a parameter, then you don't have to build this. Okay, so this is another thing. And after that, what we will do, after that we will see something like exactly how vectorization is happening. So I will define here one x1, or you can give your vectorized training set. In this you will define your vectorized layer, and here you will pass xtrain. Okay, so I'm using my vectorized layer and I'm applying on this vectorized layer on xtrain. Okay, so this is what we are doing here. And after that, if I show you the shape of xtrain, so xtrain dot shape, so we have 37,500 examples in the training set. And if I show you this vectorized training set, which is here, we are getting 37,500 comma 200, which means that we have here 37,500 examples with 200 columns. So we are getting here matrix. Okay, so this 200 columns, what it represent, it is representing the vectors. Here we have taken maximum length as 200. So all 37,500 examples are getting vectorized into 200 tokens. So if I show you something here, like if I print here like this, then you will see this is the vector we are getting. If you see here, we are getting somewhere 0 also. It means that this example having total token less than 200. So due to that, it's padding 0 to make it 200. Okay, and vocab is this. So this is our vocab. And let me show you some vectorized result, exactly how it's doing these things. So I'm taking my training set and I'm creating a list of that using toList, and I'm taking second element of that. Okay, so this is the second element of my training set. Don't know, film, went, unnoticed, this thing. Okay, now let's take this vectorized training set here, and I'm going to take second element of this. Okay, it's corresponding second element with all columns, because here we are getting matrix. Okay, so that's why I'm taking like this, and let me print it. So this is what we are getting here. If you see this film, don't know, film, and again we are getting somewhere film, again film. So this vectorized layer is giving this film as 3 value, and again this film is coming here, somewhere here. So again, it's giving it 3. So whatever is the index present in this vocab array, so its index it's giving here. Okay. So if you want to see exactly the index, then you can see like doing np.where if you use, and here you can give vocab, and here if you give film, then you can see the index of that in this vocab array. So index is 3. Okay. So that's why it's giving here 3. So it means that after building this vocabulary, after building this 20,000 vocabulary, when we are applying this, vectorization layer on our training set, then what it's doing, it's taking each words, it's taking each word and it's mapping it with its index. So that is what it's doing. Okay. So for each word we are getting here its index. So here we have defined in such a way that if something is coming more than 200, then it's truncating it. It's just considering first 200 words. And if something is coming less than 200, then it's giving rest all to 0. So what is 0? So 0 is here empty. Okay. So in this vocab, we have this 0 tag. So it's saying that it is empty, nothing is there. So that's why we are mapping it. We are mapping it with this empty. And if some word is coming which is not a part of this vocab, full vocab array, then we are giving that word to this. We are mapping that word with 1, which is unknown index. Okay. So that is what we are doing here. Okay. So here if you see we have this one also. So this is the word which is not part of that vocabulary. Why it is not part of that vocabulary? Because this word is not in the first 20,000 rank. Okay. That's why it is not a part of that vocabulary. And here if you see we have 1 2 3 4 5 6 at 6th position. 1 2 3 4 5 6. This longi, this is also a not most frequent words. So it's also vectorizer is mapping it with unknown. Okay. So that's all for this video. I hope you understand the exact thing how text vectorization works, and we did some deep diving here. So here you we can give here comment. Okay, so building vocabulary, and I'm removing this. We don't need this, and here I can give small markdown that applying vectorization on training set. So we are applying our vectorization on training set, and this is what we got after vectorization. And so after that we understand, okay, what is these things, how this is coming, what is this unknown and all. And so basically we are mapping with the index of vocabulary in this. Okay. So vocabulary creation is very important. Once we got the vocabulary, then based on that we will map and we'll get this vectors. Okay. So we got our vector for all training examples. We got our vector. So this is our vectorized training set. We will use this vectorized training set to train our LSTM model. So in the next video, first we will understand why we are going to use LSTM model, why not CNN, and after that we will start building our LSTM model. Okay. So that's all for this video. I hope you like this video. Thank you guys. Thanks a lot for watching this video.